Hi, welcome to the first lesson from topic 11, static electricity. In this lesson, we're going to introduce the concept of static charge and how it forms. Now, before we move into the concept of static charge, let's first recap the basics of charge. Here we have some pairs of charges, both positive and negative. They're in pairs if you see. How do you think they're going to interact? Pause the video and think. So, the first pair are both positive, and in this case, they're going to repel. Next, we have a positive charge and a negative charge. In this case, they're going to attract. Next, we have a negative and a positive. And these opposite charges are also going to attract. And below that, we have two negative charges. And these are the same type and are going to repel. So, from this, we should be able to see that objects with the same electrical charge will repel, as we can see here. Two positives will repel and two negatives will repel. Objects with the opposite electrical charge will attract, as we can see here. Positive and negative attract. And the key concept to note is that a static charge is an electric charge that cannot flow. This is extremely important. And having charges that are static and cannot flow can be very useful for several applications, and we'll cover those in the coming lessons. Whether a charge flows or not depends on the material in question. If the material is a conductor, charge is able to flow very easily, and metals are a great example of this. On the other hand, insulators do not allow charge to flow, and plastics are a great example of that. If we look at an electrical wire, as we have here, this is the type of wire you often see in a plug or in a building. There are two materials here. First, we have copper, and this is a metal, and it's found on the inside of the wire. It's an extremely good conductor, and it allows electricity to flow through it from the electrical supply, perhaps a battery, onto the appliance such as a bulb. We also see a plastic covering to the wire, and this prevents charge escaping in other directions, in this direction and this direction, and charge is only allowed to flow as a result in these directions. These casings are extremely important as they prevent charge escaping the appliance and potentially electrocuting someone. Based on this, we can see that insulators do not allow charge to flow. They force charge to build up. Therefore, insulating materials are considered when thinking about static electricity. In fact, when two insulating materials are rubbed together, like we can see here, this friction causes electrons to be transferred from one material to the other. So in this case, electrons are transferred from the cloth to the comb. And this causes this comb here to become charged. This allows static electricity to build up, and it allows the comb to pick up these pieces of paper. Let's take a closer look at this phenomenon. Here we have a jumper and a balloon. Both of these are made out of insulating materials. The jumper made out of wool, and the balloon is made out of rubber. Both of these are insulating materials. Now, like we saw before, if we rub two insulating materials together, they develop a static charge. Let's take a look. We're going to rub the balloon onto the jumper. Here we can see that as the balloon and the jumper were rubbed together, electrons were transferred from the jumper onto the balloon. And now we can see this balloon is relatively negative. It has a negative static charge. And we can see that it's static as the electrons aren't flowing. They're stuck and built up in one place. On the other hand, the jumper is now relatively positive. It has a positive charge. Now let's go back and think. We have positive on the jumper and negative on the balloon. What do you think these two materials are now going to do? Pause the video and think. So, you should have figured out that if I let go of this balloon here, it's going to be attracted to the jumper, because as we know, positive and negative attract together. Let's take a closer look at this. This material here represents the jumper that we just saw. And now we're going to rub the balloon against it. Just like that. Let's take a look at that again. As we rubbed the balloon against the jumper, electrons were transferred from the jumper to the balloon, like so. Now we can see that the jumper has more positive charges, and the balloon is negative. The jumper now has an induced positive charge as it has lost electrons, and the balloon is now negative, which causes it to be attracted to the positive jumper. That's it for this introduction to static charge. I hope you found it useful, and please do ask any questions if you have them.